So in this class, we've talked about a lot. When we solve, we do opposites, 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 right? Opposites, opposites, opposites. However, there is a fancy way to say opposite in math. Inverse. Inverse is like the technical way to talk about opposites. So here it says, to solve an equation for x, we use inverse operations, meaning the opposite operations. Operations, of course, can be like adding, subtracting, multiplying, dividing. The inverse of that is subtracting, adding, dividing, and multiplying, right? Just the opposite of whatever you have is the inverse, and it undoes the math. It lets you get to your x, so you can get x by itself. All right? So for each of the following, we're identifying the inverse operation that you would do to both sides to get the variable by itself, right? X plus 3 equals 7. What do I need to do? I would subtract 3 from both sides. Why do I do that? Because, yeah, I don't care what x plus 3 is. I want to know what x is, right? I don't want x plus 3. I want x. 5x equals 30. I don't want 5x. I want x. So I divide by 5 by both sides. Right? Now, we got to do both sides. On our test, some of us just squared one side or raised one side. You always do it to both sides. Otherwise, it won't be equal anymore. Because you're doing something to one side, you're not doing it to the other side. And then I have the square root of x equals 2. Well, I need to do an inverse of a square root, which is a square. So I'd square both sides, right? And why do I do that? Because I don't care what the square root of x is. I want to know what x is, just x. Okay? Hopefully you see a theme here. We want x, not something x. Not something x divided by anything. Not x plus anything. We just want x. So we get rid of, we undo, we move away. Okay? Now, a little sidebar before we get into the bottom part of the notes. Okay? Let's talk about what we did yesterday, right? Or last class. We had a triangle. A right triangle. And say it was like 30 degrees here, right? And maybe I told you, okay, your hypotenuse is 15. And then I said, hey, what's that side? Right? That's where we're coming from. Okay? In this case, you'd be like, all right, this is my angle, that's adjacent, that's hypotenuse. So I'd say the cosine of 30 equals x divided by 15. Right? And you solve for x. Yeah, that's okay. You would multiply by 15, you'd get your answer, right? That was yesterday's problem. I'm going to change the problem on you, and then you'll see where we're going. Okay, what changed? X, well, what do we have now and what do we not have?
We have the adjacent.
Okay. So what goes there instead of the angle? X. Okay, now think about what we just talked about with inverse operations. I have cosine of x equals 12 divided by 15. Nothing's multiplying by x. Nothing's being added to x. Nothing's square rooting x. But nonetheless, I don't care what the cosine of x is. I care what x is. So I need to get rid of cosine. So I need to know what the inverse of cosine is, right? Close, yeah. Cosine to the -1, which is another button on your calculator, right? If I can undo that cosine on both sides, then I'll just have x. So I'm going to do the opposite of cosine, bless you, opposite of cosine, and then it'll just be x, and then I'll have my answer, right? And it looks like this, and then I'll back up and I'll explain, okay? You would say cosine to the negative 1 of this and cosine to the negative 1 of that. This cosine to the negative 1 and this cosine cancel. And you get just x equals cosine to the negative 1 of 12 over 15, which is a button on your calculator. We'll talk about in a minute. Put that in, enter, and you find your angle.
36.8. So it's 37.
Sounds about right.
Is it right?
I don't know. I just made this problem up. I have no idea. This is just like where we're going. Okay? Now let's take a step back. Okay. So if you have sine of x equals a ratio, a over b, a number over a number, and you just want x, you don't want sine of x, you would do sine to the negative 1 on both sides, cancel, cancel, you just have x, and you get x equals sine to the negative 1 of a over b, of the ratio. Okay? Same thing for cosine. Cosine to the negative 1 of cosine of x, those will cancel. Cosine to the negative 1 of a over b. Cancel, cancel, and I get just x on that side, and then I have cosine to the negative 1 of a over b. And what do you think is going to happen for tangent? The exact same thing. Tangent to the negative 1, both sides. Cancel, cancel. And I get x equals tangent to the negative 1 of my ratio, whatever those sides are divided by each other. Okay? So, in each of these situations, sine to the negative 1 of x, sine of x, and then you sine to the negative 1, what happens? What does this result in?
Inverse
This equals what?
x.
X, right? Because these cancel each other, right? That's the opposite, and you just get x. That's the opposite, and you just get x. That's the opposite, and you just get x. Okay? I think I skipped a thing here. Yeah, so like any inverse function, inverse trigonometric functions undo math. They undo the trig function, and they allow you to crack in and get to that x. All right, so let's look at an example. Oh, actually, one more thing first. The input value of an inverse trigonometric function is always a ratio or fraction. So the thing you put into an inverse is always a ratio or a fraction of the sides, the measures of the two sides. The output, what pops out of an inverse function, is always a what?
Angle.
An angle, right? So, for example, here's an example below. Okay? Consider the triangle below. The opposite, we're going to start with something where we have all the pieces, right? And we just got to make sure we can set it up. The side opposite of 30, we know, it's 5. The hypotenuse, we know, it's 10. So we know the ratio of the angle. In other words, we know that the sine of the angle is 5 over 10. Okay? So we know sine of 30 equals 5 over 10. But now we're going to pretend we don't. We're going to pretend that this angle is a question, is an x. So let's change that to sine of x equals 5 over 10. And we have to find that x. Now we know it's 30, but this will be a nice way to see that this works, right? So how do I get just, I don't want sine of x, I want x. What do?
Multiply.
No multiplying.
Sine negative 1.
Sine to the negative 1 both sides. Sine to the negative 1. On this side, cancel, cancel, I get x. On this side, sine to the negative 1 of 5 over 10. Now, pick up your calculators. Okay?
30.
Go to your sine button. Above that is sine to the negative 1. It's in little writing, right? And you need to press the second button to get there. Okay? So you do second sine, and then instead of sine, it does sine to the negative 1. Second cos, cos to the negative 1. Second tangent, tangent to the negative 1. So you see where it says sine?
Yeah.
See above that?
Yeah.
Like the little writing, what does it say?
Sine to the negative 1.
Sine to the negative 1. So there's a button on the top left of your calculator that just says second. It means second function of a button. So if you hit that, it'll do the second function of that button. And then you have access to all those little writings behind every button. Okay? So you do second first, then sine, and it'll go sine to the negative 1. Then you put 5 divided by 10, press enter, and what do you get? 30. So it works, right? So x equals sine to the negative 1 of 5 divided by 10, x equals 30. Okay? Make sense what we're doing? Questions? All right. Now, one thing, always check that your calculator is in degree mode. Otherwise, you will not get 30. You will get some other answer. All right. Okay, we will do one more example together, and then I will let you get some work done, and then I'll give you your homework. All right, so here's an example of an unknown, okay? Looking at this triangle, first thing we notice is, oh, it's the angle that we don't know. So right away we're like, oh, this is going to be an inverse trig function, not a trig function, an inverse trig function. But we still do the kind of comparison. What do we know in comparison to it? Well, what's the 9 to that angle? Opposite. What's the 20 to that angle? Adjacent. Okay? So we're going to be dealing with TOA, tangent, right? So we know the measure of the opposite side is 9. We know the angle of the adjacent side is 20. So therefore, we know the tangent of the angle. And we set that up. We don't know the angle, so we put x. We say tangent of x is 9 divided by 20. Right? And then we don't want the tangent of x. We just want x. So we do tangent negative 1 of both sides. Right? They do that for you down here. Tangent negative 1 on both sides. So you have 9 over 20 here. They cancel over here and leave you with just x. And you get x equals tangent to the negative 1 of 9 over 20, which is
24.2.
24. Okay? Process makes sense, right? Now, that's basically it. What I'm going to do now, this gray box here is just like all the steps summed up, right? I'm going to fill them in without talking. You can go ahead and do the 4 problems below that. When you finish those 4 problems, and I'll put the answers up at some point, but when you finish those 4 problems, come show them to me. I'll check that they're correct. Then I'll hand you your homework. Okay? And you'll have a lot of time to work on it. What's that? I'm going to fill this in, the 4 below that. Okay. All right, so homework. Remember, your first step with these is you have to be able to know how to find the different pieces, the opposite, the hypotenuse, the adjacent, right? So this first question was regarding that. Can you identify the pieces and set up these equations, right? You notice each one of these deals with p, sine p, cosine p, tangent p, right? So first thing you do is you lock in on p. And you say, okay, p is my starting point. Everything is related to p. Where is everything in relation to p? The 5 compared to p is where? It's the opposite. Yeah. The 12 compared to p is? It's next to it, so it's adjacent. And then the longest one across from the right angle is always your hypotenuse. You have those pieces. Now, you remember that sine is so, cosine is ka, and tangent is toa. And you just need to plug in each piece, right, for each one. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay? So sine of p is its opposite over hypotenuse, or 5 over 13. Cosine is adjacent over hypotenuse, 12 over 13. And tangent is opposite over adjacent, or 5 over 12. That's your first step. You got to be able to set up the equations. And this triangle has everything, right? Usually something's missing, and you have to find the missing piece, right? Which is what the next section was about. All right, in the next section, there are two types of situations where you're finding a missing side, where x is on top and x is on the bottom. So we'll do one of each. Then we have a preference on one. Number 10. 4. So 4 will, oh no, that's 5. All right, 4 will work. Okay, so lock in on our angle. And then I start labeling things. What is the x compared to the angle? It's opposite. Now, just because it's on top doesn't make it the hypotenuse. The hypotenuse can sometimes be on the bottom, across from the 90-degree angle, and then adjacent here. Okay, so then I think, okay, what am I dealing with? Because I have O and I have A. So, ka, or toa? Toa. So I have tangent of my angle, 50, equals opposite over adjacent, x over 4. Right? First thing I do is set up that formula, and now I just have to solve it like any other equation. To get x by itself, well, x is being divided by 4, so I multiply by 4. Both sides times 4, and what happens is you get x left on one side and 4 times the tangent of 50, and then your calculator does that for you. 4 times tangent 50, enter. And if you do that, you get 4.8, exactly. And then last thing you can do is sense check. You're like, all right, if this is 4, this is longer than that, 4.8, okay, cool. Got it. All right, now the other version of this, we'll do number 10, is you set up the equation and you're like, uh-oh, x is on the bottom. But we have a solution for that too. Okay, so again, we lock in on our angle right here. And we think about what these things are related to it. So I have this thing across from it, so I know it is opposite. This is across from the 90, so I know it's hypotenuse. And then our adjacent is right next to it. So the two things that we actually are dealing with are opposite and hypotenuse, or OH, so I'm dealing with so. So I do sine of 29 equals opposite, which is 18, divided by x. Okay, now you might be tempted to be like, oh, multiply both sides by 18, but that won't actually cancel anything because that would just be 18 times 18, right? Question?
No, I was just going to answer.
Yeah, go ahead.
You multiply by x and then divide by the sine of 29.
Okay. So you multiply by x. These x's cancel. You get 18 equals x times the sine of 29. And then you divide by sine of 29, sine of 29. And you end up with x equals 18 divided by sine of 29, which is what? 37.1. Okay, now, notice what we ended up with, and notice what we started with. Sine equals 18 divided by x equals 18 divided by sine. What changed? This and this just changed places. That'll happen every time. So once you set this up, if you just remember that, you can just say, oh, I can switch their places. X equals 18 divided by sine of 29. You don't have to do all those steps. Does that make sense? That will happen every time. Okay? So those are your two types of problems. Now, when it's all set up for you, it's a little easier than when you have a word problem. So let's go to the back. The first four were kind of drawn a little bit for you, and then the next three where you had to draw your own picture. So in the first four, do we have anything that we would like to see? And then we'll talk about the next three. 12. Okay. So it's a kite, and we're finding the horizontal distance from the person to the kite to the nearest foot. Horizontal, that way. Vertical, that way. And it even marked it for us. This is our x, right? We want the horizontal distance, right? And then this is our right angle, right? Here is our angle, right? And then it gives us a distance on the diagram. So just like the problems before, now you might have to draw this picture yourself, right? But in this case, they drew it for you. We would label everything. This is our angle. I'm locked in on this. So what is this x compared to it? Adjacent. And what is this 100? The hypotenuse. So I'm dealing with a and h, therefore I'm dealing with cosine. So the cosine of 55 equals x divided by 100. Got to get x by itself, so I multiply by 100. X equals 100 times cosine of 55 in my calculator. And I put that in, and I get 57 feet. And that's a reasonable number because the whole hypotenuse was 100, and it's definitely less than that. It looks like almost half of that, so, or a little more than half of that. So 57 seems about right. Okay? Now, eventually you got to draw your own pictures. So let's go down to where that happened. 16, 17, 18. Any preference? 18. All right. So a staircase makes a 35-degree angle with the ground. I just start drawing when I see these. All right? Staircase, when I see something or I read a word, I draw it. So I drew a staircase. I also need to draw the ground. All right. How tall is the top of the staircase? Okay, so that's talking about this, right? Also, this needs to be a triangle, so I'm going to add that line right there, okay? And then I see the right triangle, okay? It says it makes a 35-degree angle with the ground, okay? If this is the staircase and this is the ground, where do they make an angle? Right? Yeah, right there. So that's 35 degrees. It also says how tall is the top of the staircase. This is the tallness, so that would be x. And it says if the horizontal change is 6 meters, which way is horizontal? Yeah, so this has to be 6. Right? And now I have it just like the other problems. Okay? I'm dealing with, if this is my angle, this is what compared to it? A. And this is what compared to it? O. I'm not dealing with an h, so I'm dealing with tangent, TOA. So tangent of 35 equals, oh, I know why you asked about this one, x over 6, and multiply both sides by 6, x equals tangent 35 times 6, so x equals 4.2 meters. Except, what did the answer key say?
It says 3.5 on the answer.
And it was wrong. I'm sorry.
But if you're rounding it to the nearest meter, would it be 4?
Okay. Yeah, it was super wrong. Yep. Okay, so sorry about that. I'll fix it for next year. I know that doesn't help you. All right. Make sense yesterday? Last class, I should say. All right. Now, we're going to move forward. So I'm going to hand out your notes. When I